Allied Machine and Engineering Corporation presents their guidelines for deep hole drilling. You will first need to recognize if the drill you are using is considered a deep hole drill. Keep in mind, this is not limited to the TA product line. Extended, long, XL, 3XL are length categories that are subject to deep hole drilling guidelines. These categories are listed beside the item numbers in the catalog. Over 9 times diameter of the body length are also subject. Allied Machine attaches a label to these tools affected to help make you aware that precautions will be necessary. When operating an Allied drill, recommended speeds and feeds can always be found in the back of the catalog. First, identify the material category that you are machining. Then you will choose your material's hardness range. Depending on the coating you have selected for your drill, the recommended speed will change. Next, select your drill diameter's range to attain the recommended feed rate. When using a deep hole drill, speed and feed reductions must be applied. At the bottom of each speed and feed chart, you can find the reduction information as well as the necessary formula. Now that we have identified the deep hole drills and learned how to make speed and feed reductions, let's continue the deep hole drilling process. We will discuss each step of the process as well as watch an example of an 11/16 diameter TA drill into 12 inches of 6061 T651 aluminum. Step 1 is to establish a pilot hole using the same diameter but shorter drill to at least a 2 times the diameter drill depth. Your pilot drill should have the same or larger included point angle to make sure that the deep hole drill engages the point first. In this video, notice that the length of the drill is shorter. Step 2. Using the deep hole drill, feed into the pilot hole 1/16 of an inch shy of the bottom. This must be done at no more than 50 RPM and 12 inches per minute feed. If the deep hole drill is not engaged in the part or in a bushing, you should never rotate the drill at more than 50 RPM. Doing so could result in tool failure and/or personal injury. In this video, take note of the low RPM of the deep hole drill. Step 3. Because you do not want to go from low RPM in feed, you will need to transition into your calculated reduced speeds and feeds. To do so, drill an additional 1 times diameter past the bottom of the pilot hole. This should be done at a 50% reduction of recommended speed and a 25% reduction of recommended feed. You will want to add a dwell to allow the spindle time to increase its RPM. Step 4. For a blind hole, begin drilling to the bottom of your hole at the speed and feed you calculated. A peck cycle is not recommended. However, good chip formation must be obtained for a deep hole drilling application. Contact Allied's Application Engineering Department for assistance if chip formation is not acceptable. Step 5. If the hole you are drilling goes completely through the part, you will want to again reduce speed by 50% and feed by 25% prior to breakout. This is similar to the transition drilling discussed previously. You do not want to break out more than 1/8 of an inch past the full diameter of the drill. Once again, anytime the drill is not engaged in the part or a bushing, precautions must be taken for safety. Step 6. Make sure you reduce the spindle RPM to 50 or less before completely retracting from the hole. Failure to do so could result in tool failure and/or personal injury. A copy of the deep hole drilling guidelines are available in your catalog or on our website. Allied Machine and Engineering Corporation's intent is to produce and market safe products and practices. An application engineering support team is available for any questions or concerns you may have. Feel free to call or email them for assistance.